Hi class, welcome to our very first video for our climatology class. In this video, I'll just be introducing you to the climate system. So what is climate? From the Free University of Berlin, climate is describing the long-term and average weather conditions for a specific region, long-term with a minimum of 30 years. From Hartmann, he defined climate as a synthesis of the weather in a particular region. He said that it can be defined quantitatively by using expected values of climatological elements during a certain month or season. So these meteorological elements can be annual temperature or monthly temperature or the amount of rainfall and many others. Another definition from Marshall and Plum, they define climate as the average weather with an averaging period long enough to smooth out the variability of synoptic systems. So these synoptic systems points to tropical cyclones. It also can be monsoon events, fronts, and the like. From Wallace and Hobbes, the term climate refers to the mean state of the atmosphere and related components of the Earth system, and it is also used in reference to atmospheric variability on timescales longer than the 2 to 3 week limit of the most deterministic atmospheric predictability. So knowing all that definitions, why do we need to study climate? Here are just some few reasons. It affects soil and vegetation distribution. Climatic fluctuations threaten agricultural productivity, which can cause mass starvation. So for industries the in the agricultural sector, knowing the climate is very vital because this can greatly affect their yield or harvest, and shortage of food can really cause mass starvation. Also, climatic anomalies can cause serious harm to humans, properties, as well as the environment. Also, it affects our culture, the way we dress, the type of clothes we wear, as well as the way of life. So this is an article from National Geographic News written by Nicholas Mott with the title Why the Maya Fell: Climate Change, Conflict, and a Trip to the Beach. Initially, people thought that what brought the Mayan Empire, take note that during their time the Mayan Empire was an advanced empire. Initially, they thought that what brought down the Mayan Empire was some cataclysmic event. But now evidence show that it is actually climate change. So it's really important for us to study climate. Climate can threaten even an advanced empire. And it really can cost an empire its life. So what are the applications? Number one, we have climate prediction, of course. Number two, agriculture and food production, crop planning. So in Pag-asa, we have reports or forecasts from the climatology section that deals with crop forecasts for farm weather. Also, we have power, for example, rainfall monitoring for dams, hydroelectric, wind, or solar. Also, it can be applied in engineering and construction. So I remember if you have been to Baguio, if you know SM Baguio, they don't have much, or I don't even know if they even have an air conditioning system. But the climate there is so cold that they don't need one. So that's one unique mall from the SM group. So that's how we apply our knowledge of climate from in engineering and construction. Also for transportation, tourism, and recreation. When you, for example, for tourism and recreation, when you know the climate of the place that you would you'd want to go, then you would know how to dress properly, what things to wear, and what activities can you do in that place. So climate is really important in our everyday lives. So climatic controls. What are these climatic controls? The world's many climates are controlled by the same factors affecting the weather. So, for example, here in the diagram, we can see this is actually the mean sea level temperature in degrees Fahrenheit. So, you can see the darker orange colors at 0 degrees. So, we're nearly at 0 degrees. So, we have at least or an average of 80 degrees Fahrenheit mean sea level temperature. And as you go up from 0 to 90 degrees, you can see that gradually the temperature decreases. So, what are these factors? One, intensity of sunshine and its variation with latitude. Same with what I've shown you about the climate um, affected by the location with regards to the latitude. And next, we have distribution of land and water. Next, ocean temperature and currents. Also, we have mountain barriers. You know that on a local scale. Also, we have land cover. And lastly, we have atmospheric composition. So, climate varies from place to place. So, even in the Philippines, we have many types of climates. So it varies from place to place. It depends also on latitude, distance to the sea. Even in the local setting, we have very different climate when it comes to when you compare a place in a mountainous area and a place near the sea. Also, it can be affected by vegetation, also presence or absence of mountains, and other geographical factors. It also varies in time from season to season. So in the Philippines, we have wet and dry seasons from year to year, decade to decade, or on a much longer time scale, such as the ice ages. Statistically significant variations of the mean state of the climate or of its variability typically persisting for decades or longer are referred to as climate change. So any variation, any significant variation from the mean state of our climate is referred to climate change. Climate variability refers to long-term variations or changes in the mean state. So what are these variability? It can be intraseasonal climate variability. It's month-to-month variation about the seasonally varying climatological mean that occur within the same season. So for example, the distinction between an abnormally warm January and an abnormally cold February. So like that. We also have interannual, so year by year variability. It denotes year-to-year variations of annual or seasonal averages. For example, between the mean temperatures observed in successive, let's say, winter seasons. Also, we have decadal century scale or the larger scales. Denotes decade to decade, century to century scale variations. So, when we are talking about the climate, we are not solely talking about the atmospheric component. It's actually a system, the climate system. So, what we have here, initially, we only have um, the atmosphere, hydrosphere, cryosphere, lithosphere or land, and the biosphere. But then recent classifications of these spheres include now anthroposphere. So we'll be talking more about that in the next few videos. So the climate system components, just a sneak peek. So the atmosphere, thought as the fastest changing and most responsive component in the climate system. It's previously considered as the only changing component. Next is the ocean, the other fluid component covering 70% of the surface. So this tells us that the role of oceans in climate is really very huge because it covers 70% of the earth, plays a central role through its motions and heat capacity. So maybe you are thinking that it's only the atmosphere that transports heat from the equator to the poles. It's not. It's also the ocean. It interacts with the atmosphere on days to thousands of years. Cryosphere. So this is closely very related to the hydrosphere. It includes land snow, sea ice, ice sheets, and mountain glaciers. It's the largest reservoir of fresh water. It has high reflectivity and low thermal conductivity. So if there is any threat to the cryosphere, it can greatly affect the climate. Also, we have land and its biomass. So in the previous diagram that I've shown you, this can be broken down into the biosphere. It can also include lithosphere and pedosphere. It's slowly changing extent and position of continents. So that can also affect, but it has a very slow pace. Faster changing characteristics of lakes, streams, soil, moisture, and vegetation. So that is the pedosphere. Also, the anthroposphere, human interaction, agriculture, urbanization, industry, and pollution. This is now very real that the humans are now causing great impact to the local climate and even the global climate. So this I'm showing you a very simple diagram that discusses forcings and responses. For example, we have external forcing like changes in plate tectonics, changes in the Earth's orbit, and changes in sun strength. It will now interact with the spheres or the Earth systems that we've mentioned a while ago. This three can affect the atmosphere, most probably from the changes in sun strength. It can also greatly affect vegetation. It can greatly deplete the ice, and it can warm the ocean. And these Earth systems are also closely interacting with each other. And after that external forcing, there are what we call responses. So it can be change in the atmosphere, it can be changes in ice or the amount of ice that we still have. It can also change it can also trigger a change in vegetation, changes in ocean, and changes in land surface. So forcing and response. For example, we have here the Bunsen burner experiment. So the forcing is actually the source of heat as or the Bunsen burner, and the Earth system is depicted by that flask with water. If it it is heated, normally the water will become warm, and eventually it will boil. So that's the response, the temperature of the water. The mean state of the climate system is determined by emission of radiation from the sun, the Earth's rotation rate and orbital characteristics, the composition of the atmosphere, and interactions between the atmosphere and the other components of the Earth system that determine the fluxes of mass, energy, and momentum at the Earth's surface. So take note, it's not only the atmosphere that we are talking about, or we are only taking in consideration when we are talking about climate. It's an interaction between the atmosphere and all the other Earth systems. So in this table, I'm showing you response times of various climate system components. So for example, we have the atmosphere. Its response time is, so this depends on the forcing. So response time, for example, in the atmosphere, it can be hours to weeks. For example, we have daily heating and cooling. So that's just an hour to a day. Also, gradual build up of heat wave that can last for many weeks. For the land surface, can be hours to months. So if there is a forcing, for example, um, increase in temperature, it can cause midwinter freezing and thawing, so ice melt. For the ocean surface, it can be days to months. So it can cause warm beach temperatures or warmest beach temperatures late in summer. Also, hours to it can have hours to decades or centuries response time to vegetation. It can cause slow growth of trees to maturity. For sea ice, we have weeks to years. So these are under fast responses. For slow responses, we can have mountain glaciers. So we can observe this for 10 to 100 years. Deep ocean, since uh, normally what gets warm are just a few feet of seawater. So that's 100 to 1,500 years. And also ice sheets that has a response time of 100 to 10,000 years. But we'll talk more about this in the next few videos. So I've assigned each group to research about an Earth system. So that's our topic in the next video. So thank you guys, and until the next video.